Hey James,
Sarah, how are you?
I'm good, man. How are you?
Good. It's good to hear you.
Great, great, great to hear your voice.
I think we're live, and it's the 7th of August, 2024. We got Sarah, Sebastian, Harsha, Newman, and me. My name is James. We're here, and we are learning Cardano development together. And we've been working through a lesson and also like kind of studying some of our ideas about teaching and learning at the same time. So it's been a really exciting process these last few sessions. And Harsha, what do you say? Should we pick it up where we left off yesterday and keep going?
Yeah, for sure. Let me share my screen. All right.
All right, so what kind of code is this?
This is the validator script, I think. Yeah.
Okay, so we were reading through this reference token pair validator script yesterday, and we went deep into the details. Do you have any lingering questions, Harsha Newman, or anybody else about what we're looking at here?
I have no lingering questions, but should I just summarize what I understood, just so people get a frame of reference as to where we are?
I love it. Yes, please.
So what we are trying to do is we are trying to change the metadata of a token using the SIP68. And in the SIP68, two tokens are created. One token exists in your wallet, and the other token is called a reference token, and that either exists in a validator or it exists in someone else's wallet. And if you want to change the metadata of one of these tokens, you just need to change the metadata on the reference token, and then it naturally changes it on the token in your wallet as well. Is that all correct, James?
It is. It is. And the one thing to clarify here is that a script like this is not required. All right. We're just adding on top of what's suggested in SIP68. And we're saying, well, if there's a reference token somewhere, can we write some custom rules about how the datum on that reference token can be updated? But it's not a requirement of SIP68 that you make the datum updatable according to any rules.
Makes sense. Let me. Okay, so I think we finished step two yesterday.
We got ourselves right up to ready for step two. And
Oh,
so the
okay, okay.
last thing in that file that you've already got open, let's just review that last concept one more time, because this is critical to Cardano development. Online, I think it was 23. Yeah. Where we define this validator, it would be fine for those parentheses to be empty, right? You see where it says reference token symbol is value.policy ID. We could leave that part out. We could, for example, down on line 37, we could
38.
just, yeah, like in between lines 36 and 38, in that blank space, we could add a new line where we hard code some policy ID into this validator, right? And we could say, okay, this validator is only going to work with this policy ID. But we didn't do that. We made it a parameter of the validator. And this is a crucial pattern because what it means is you can write validator logic one time and then you can reuse it across many instances. That's a, to me, that's a key way to implement decentralized or permissionless systems. Write the logic, but allow other people to plug in what policy ID they want to use with that logic. Does that make sense?
It does. So basically this script will exist on chain and anyone would be able to use this script. Is that correct, James?
Oh, okay. Well, so that would take us into a cutting edge of our work. And so for now, the answer is not quite. What
Oh,
we
okay.
need to do is use this code right here, apply whatever parameter we want to it, and then we're going to have a unique reference script that we can deploy. Okay. And then it'll be on chain. So once it's on chain, it's already had the parameter applied.
Yeah, I think I get that.
Okay. Now, there is some fabulous innovative work happening right now around deploying scripts that don't have the parameters applied yet. So, Mix has been thinking about this. Hey, Mix. Adrian's been thinking about this. All the guys at Mesh, Michelle building Plutus has been thinking about this. There's a lot of people thinking, how can we make a script that has yet to have parameters applied even more accessible to people? But to go into the details of that, let's save that for a deeper dive later.
And Harsha, you get that, like this, all of this Aiken code, all this code like spits out that big blob of CBOR, and that's what goes up on the chain. So once it's in the CBOR, the parameters are set, the policy IDs and whatnot are set. But this could be used once it's in the Aiken for instance, doing other other policy IDs, other tokens, so it can be used by different folks to build this SIP68 style split token, or yeah.
And so let's review how we did the first step of building this. And so open up that terminal again, actually, Harsha, and let's stay in the terminal. We're going to use some terminal commands. Just do an ls to see what directories you have. And let's now cd into Aiken examples. So you can start typing cd PPBL and then tab. Right. And if you press tab twice, now it shows you your options. Now you press dash and start typing 2024. And you can press tab again right there. Okay. And now you press A for Aiken and it'll autocomplete because there's nothing else with that string. Now from here, we still have to go down one more level. We're going to cd into reference token pair. So ref tab. That looks good. And then we ran Aiken build, and you can do it again just to demonstrate this part. And sure enough, it works. No errors, no warnings. That's what we want to see. Now, the output of that Aiken build command is the plutus.json file you see right there. And this already has one of those big chunks of CBOR that Newman was just talking about. So there's a little bit of compiled code. And I think, does Control Z do anything if you press that right now?
In the terminal or
inside the code window, inside the
Okay.
editor, tap Control Z. Does that do anything? No. Okay.
Command Z or Control Z?
Try
undo.
Try Alt Z.
Alt. So I don't know what Alt is in the Mac keyboard.
What are you trying to do, James? Like, what would
Trying
you expect?
to text wrap that really long string,
Oh,
the CBOR string. The button next to the right of command, hold that and tap Z. Does that work?
On
doesn't
the option
Option Z?
option Z. Okay. Okay.
There it
look
is.
at you. Awesome. Awesome. Yay.
All right, so now okay, there's our big blob of CBOR that we've come to expect, okay? But now there's another thing that's really cool in this file. If you keep scrolling down, this is a blueprint file. These are still we're still figuring out as a development ecosystem how best to use these. And there's actually SIPs around this as well. But you can see just by looking at this, this is a really helpful attempt at creating kind of a common data structure that's going to make it much easier to move between tools. It's really nice. And you can see we've got our redeemer defined right here with so those titles, right, are all the names we gave to our redeemer type. But at the top of this page, before the CBOR, what do we have here? Parameters, line 28, okay? And so this is basically showing us that we have parameters that need to be applied before we have a usable instance of this validator, okay? Now, those parameters can be applied in many different ways. And in fact, it's even more convenient just to take the compiled code from line 36 and drop it into a library like Mesh or Lucid that now have the ability to apply some parameters. And when you look at the Aiken gift card tutorial, you'll see how to apply parameters with Lucid. We're going to, for now, apply parameters here in the terminal, recognizing that later we're going to learn other ways to apply them. And so go back to the lesson to check our status. Here's how to do it. Okay. Aiken blueprint apply. And then the -- out part just means we're going to overwrite our plutus.json file with a new file called plutus.json. So drop that into the terminal, but before you press enter, that's okay, just stay right there for just a second. In your code window, scroll up to line 28 again. And we're just going to watch this part after we finish running this command. All right, now, the parameter here is a policy ID. And actually, in the first part of this lesson, you generated a new policy ID. And it's saved right here in one of your directories. Transactions, I think. PPBL 2024 transaction, module 203. You ran the script to create, SLT 2034.
Yeah.
And then you made this test token, right?
Nice.
And that has a currency symbol. It's the bottom green file test token. Let's use that as the parameter for Aiken. So copy that. You could paste that into the terminal, but before you press enter, try to get that Aiken file back up on the screen so we can watch what happens.
Nice.
Yeah, let's look at line
Line 28.
Oh, and it's the plutus.json file, right? This guy. All right. So now when you press enter in the terminal, watch what happens right there. No more parameters. They've all been applied. And the CBOR string down there on the compiled code, line 28, what's now on line 28 anyway, is almost the same string, but it's had some parameters applied to it. Okay. I don't expect anybody memorized this string earlier, but it's different. Any questions about that step?
And that basically is the blueprint. It's like a little script that asks for these parameters. It's I think I get that.
Yeah, Aiken gives us a bunch of different tools. You can see like Aiken -- help to see what all of them are. And especially interesting is like Aiken blueprint dash dash help. And you can see some of the different commands that are possible. So we ran apply, but actually, if you look back at the lesson, you'll see we're going to do another one of these commands next.
Convert. Okay.
And so what this does is it wraps the CBOR string in a couple more characters. And actually, don't forget about the greater than sign and the file name. Just in your terminal, type Aiken blueprint convert. And if you scroll up, you'll actually see this looks like a familiar file, doesn't it?
Mhm.
This is the type of .plutus file that we expect to get if we've been compiling from Plutus TX. And there's our CBOR. So the only thing that's different about the command in the lesson is that it also has that little greater than sign or arrow character, which instead of printing this result to the terminal, adds it to a new file called reference token pair aiken.plutus.
So can I tap the timeout?
Yep.
So that's CBOR. So all we basically are doing is trying all this, the Aiken and the PluTX, Plu-TS, like all the different ones, is just getting us to get that CBOR. And that CBOR is the quote unquote smart contract that goes inside of a transaction, a UTXO, that we can reference on the chain. I'm feeling
It's okay.
I'm feeling my
Very good.
metaphors starting to roll in.
Yeah. There's a little bit of language that I didn't know before I started thinking about this. But the best way I've heard it described is this CBOR is the common compilation target for all of these language, Plutus TX, Plu-TS, Aiken, and etc. Right? All of those languages allow us to write validator code that compiles to the same target. Okay. Once we compile to that common target, we now have a Plutus script that can be used in a transaction. And so that's the one thing I would update about the way you said it. We're not actually using the script in a UTXO, right?
Okay.
We're using it to govern how some inputs and outputs can pass through a transaction.
Okay. No, that's good. Thank you. Okay, game back on.
Yep. Now, in order to reference this script in a transaction, we have the
Okay.
option of putting it on chain. And if we do that, now it's going to be in a UTXO. But that UTXO is different from the ones we're going to be spending or outputting from a given transaction.
Okay, yep, I think I got that. Yep.
And we're going to see that right now. Okay, so
Nice.
now run this last command, Aiken blueprint convert. We'll save it as a file name. And the EX002, you can change that to whatever you want. I might even change it, like after you paste this, maybe you want to change EX002 to the name of your token, which was test token.
Yeah.
And that way you'll remember, okay, this is the version of this script that I compiled with test token. Nice. We save that. Now that file is over there in your side view. There it is. And this is the sort of .plutus file that I would expect to get from Plutus TX, and that now I can do several other things with. And the first thing we're going to do with it is deploy it on chain so that we can use it from elsewhere. That's step 4. This part, I'm not sure if this part is helpful because it depends on how people have their directory structure set up. But I think this would actually work for you, Harsha, because you do have these 2 directories side by side. So I think you can just copy that from right here. Yeah, if you copy and paste that command, it should work. Nope, no such file directory. That's okay. Because we are in reference token in Aiken examples, we need to go up 2 levels. Do me a favor here, type PWD, enter, and let's leave this on the screen. And then go cd ... /... So that enter, that brings us up 2 directories. Oh yeah, we were already in, okay, so we did cd correctly, but we didn't, oh, I'm being silly. Look, it's because of the file name. We can't move file EX002 because we changed that file name.
Right. Okay.
So go cd // and then PPBL 2024 Aiken. We'll go back to where we were.
Yeah. Yeah, you can just try the tab. Not working.
Yeah.
Tab should work now. Yeah.
Oh,
I just press up tab.
okay.
And then we want to go into reference token, CD reference token. Okay. And then copy just the first line of that command again, and we just want to make sure to change the EX002 to test token.
Oh, okay.
There we go, no problem. Okay, now you can run the second line of that command, just quickly CD.
What's CP?
Copy.
Oh, so it copies from one to another. Okay.
And so just give us an LS right here so we can see what files we have. And there's a bunch of different things going on. But we're about to use script 001. Let's look at that script. And you're still in the Aiken directory.
Oh,
And from the terminal, it would be like code or dot. I'm not certain what
Yeah,
it
it
would.
depends on how the environment is
Yeah.
configured in Aiken. I haven't tried it. You could try that too. But you want to
I
go
think I went.
down a little lower in your file explorer. PPBL 2024 transactions, module 203. And then SLT 2034. That's the directory we're in.
Yeah, there you go.
There we go. And now 001 is the deploy. And let's just look at this code for just a second. This is a relatively simple spending transaction with one really important thing. Line 19, we're attaching a validator file to an output UTXO. And that's going to become our reference UTXO. Any questions about what you see right here?
Harshem, giving you the honors
No, I
on the
think this
TikToks here.
is the most familiar thing. Build
Yeah,
some.
yeah, yeah. This is like now I'm back to home base from last year, right? I mean, how much time did
Yeah.
we spend in this? And we thought it was hard. We thought this was hard.
I love that.
Oh my goodness. Okay.
There's a
So I
fun
have a
little
small
okay.
I have a small question here, specifically when this UTXO is being created. So in general, when a transaction is made, something is a specific UTXO is split, and some UTXOs end up in our wallet and some UTXOs end up in somewhere else, right? In
Mhm.
here, when we do this transaction, where exactly do these UTXOs end up? Like all the final UTXOs that come out of this transaction?
Excellent. How many UTXOs will come out of this transaction?
I mean, my intuition is two, but I could be completely wrong because there is a sender address that means change. So at least this is one UTXO, and the reference UTXO where the script exists, that'll be one UTXO. Uh, I'm not sure what other UTXO. Maybe there. Yeah, those are the two I'm thinking of. Do you have different
That's
ideas,
exactly it.
Newman?
No, that's all
Okay.
there is.
Ah,
Oh, sorry.
well, yeah, that's a great king. I was like, oh, geez. I, no, that sounds, no, yeah, my brain's still coming up to speed from, I need to go back to this and sort of get my thing back together. But that makes sense. I mean, there's TX in and the two TX outs. I mean, that's sort of what, Occam's razor, kind of like, oh, okay, is that the answer? Because I just see one in and then two out. So
Yep. We're going to
that,
spend a single UTXO and we're going to output two of them.
Okay. Okay.
And we also know a few things. And this is where determinism gets just a little bit mind bending, honestly, because you have to fully appreciate that you have full control and um, uh, visibility into what's going to come out of this transaction. Okay. Because on line 18, we say TX out for the first time to this reference script address, we know that that's the zero index, right? That's whatever transaction hash this transaction creates. We know that at index 0 of that new transaction, we're going to be able to find our reference script. Why is it index 0? Because it's the first TX out we wrote into this transaction. Okay. And we're using that assurance on line 33. There's a nifty little thing happening down here. Right? You're familiar with Cardano CLI query, UTXO maybe. You're familiar with Cardano CLI transaction build or sign or submit. Here's another command that maybe you haven't seen. Cardano CLI transaction TXID. And what is this? This takes a transaction file, for example, like our signed transaction. Notice not our submitted transaction, right? This transaction doesn't need to be submitted and on chain to have a unique transaction hash. And I can know the transaction hash that will be on chain before this thing is confirmed, which is helpful for multi-transaction sequences where I have to wait for the next one, right? I can know all of the inputs and outputs for chains of transactions without them being confirmed on chain. And we're counting on that right here because we're going to be curious to know the transaction hash that's generated here because we're going to use it to reference our Plutus script. Okay. And there's that 0 at the end of the line. Why is that a 0? Because I know that the UTXO in question is at index 0 in the transaction that I just built above.
So the indexes are depend on the specific transaction. I thought the indexes were more to do with the address itself and the transactions in that address, no?
Love that. No, not at all. The index number, that integer, comes from the order of TX outs in the transaction that produced them.
Oh, okay, makes sense.
And that's why you'll see, like in some advanced transactions, right, that do take any number of UTXOs, but they output, let's imagine a transaction that outputs 4 different UTXOs, right? One over here to some validator address, another over there to some other validator address, one back to your wallet, and the change back to your wallet. All 4 of those UTXOs have the same transaction hash, and they would be indexed 0, 1, 2, 3.
Got it. Okay.
Okay, so should we run this script?
Yep.
So we can clear this out and look at the top of that file to see the usage. We need to provide 3 parameters, lines 6, 7, and 8. And if you look at the lesson, there's a suggestion for how to get started. Here. So we see for the first parameter, it's just a file name, right?
Mm-hmm.
And you're going to have to change that file name because yours says test token, not EXO02.
Yep.
And then what's that 0 right there? You can drop this into the command line and then we can look at it as we go. The 0 is the second parameter, which is defined on line 7.
Line 7.
Yeah.
So this is an amount of Lovelace. And for now, we're going to leave it at 0, even though you might be able to predict that a UTXO with 0 Lovelace is going to fail. But we're doing this for a particular reason.
Uh-huh.
Okay. And then that last param can be anything, but yeah, I think using the same name as your Plutus script is helpful. Where is ref going to be used? You see, we define it on line 8 and we pull in the third argument. Ref is used just at that line I was showing you on line 33. All it's going to do is be added to the name of our reference UTXO. It's in blue at the far right of your screen.
Oh, the end there. Okay.
Okay, so you'll
yeah,
know
that makes-
which UTXO, and this is really helpful if you are making many deployments of the same validator. So we're going to get an error when we run this command, but let's try to read it.
Try to read the error.
Yeah.
Once you
Okay.
hit enter, and it should give us an error. Woof.
Oh, we don't have the environment set up. That's our first error. So let's do that. You have a wallet, right, Harsha?
I should have wallet, yeah. Oh, 1 second. Keys. So I think this should be.
There's some minting keys there. And I think we had you create a wallet directory inside of PPBL 2024 transactions.
Hmm.
Let's just make one.
Yeah.
There are some helper scripts to do this very quickly, or we can look at the lesson content itself. But yeah, actually, let's stay right in the repo. Stay right here on the lesson, but in the repo, I'll show you where to find this. I think the easiest is probably module 102 because that's where, so to go back to transactions, we're staying in transactions. We're going to look back at module 102. No, that's just the assignment. Let's use Cardano CLI instead, that directory.
Create
Create
address.
addresses. There we go. Now, to make this simple, let's actually stay in the SLT 2034 directory right now. I mean, because you can always move these directories later. We're just going to generate some keys. So in your terminal, let's go cd ... Let's go up one directory to get out of these scripts. But now follow these instructions from right here. So you can step by step. Let's just make a directory inside module 203. You can call it whatever you want.
So just copy these.
That's fine. Yep. Make a directory, change directory into it. Right? The name of it really doesn't matter. And then just run these commands in sequence. Generate the keys. Remember, you're in module 203 if you're looking for these files.
Oh, yeah. Okay.
And there's your new PPBL 2024 CLI wallet, which is an empty directory, but not for long.
Oh, so I should cd into this, right?
We're already there. Yeah, look at your command line. The path is the
Oh,
same.
you're right. You're right.
Yep.
Okay.
All right, so now we got some payment keys. We make some staking keys next.
Super simple. Bing, bang, boom.
So I'm gonna query the address just to make sure.
That should be in there, right? Yeah.
Nope. Command not found.
Oh,
So
don't
is it?
copy. You copied the prompt as well. Sorry, just copy from Cardano CLI,
Oh, okay.
the red text. Yeah. All right, nice empty wallet. You want to drop that address into the chat and I'll shoot you some Tada?
No, I can send it in from my local
All right, you
wallet.
got it.
Let me see, where is the address?
It does have video game kind of feel. Like when I was 13 and playing Ultima Online on a Commodore 128, and you're just sort of sitting and watching, and like somebody's at the computer. This whole pair programming, I think, it gives me that vibe.
I couldn't agree more. Mix and I have just giggled at each other because we're like, I can't believe what I'm doing here. Like you're accessing that a second later, like throwing things on this blockchain and seeing how things work. It's so fun.
Yeah. Yeah. Yeah, I keep threatening to order a Domino's pizza and a 6-pack of Coke, and my girlfriend shuts it down. I'm like, I let her do that. She's like, man, gotta pick her battles.
Know what you're doing next time she travels. Okay.
Yeah, actually, I do. It's like it's today the day that I figure out how to like do a delivery and a pizza delivery. It's a very slippery slope. I honestly don't want to go back. It's nice to be, nostalgic, but
All right. Did any funds hit that address yet?
Let me query again. Yeah.
All right, so
There
now
you
we
go.
want to set
Sweet.
up the environment we need. Okay, so open up that script file again. This is the one thing we didn't do. The 001. And sorry, we're always going to be going back to the SLT 2034 directory in the transactions repo. We're done with Aiken.
Well, I can
Yeah, we
transaction.
want to be in transactions. Module 203, SLT 2034. And I'm sorry, that still says 2034. It should say 2033 because that's the lesson we're doing right now. There just used to be 4 lessons in this module. Maybe there will be again, and it'll be correct again. Okay, so at the top of this file, you see lines 3 and 4. It says dot space dot dot. Actually, Newman, going back to that word source, the way you say that dot at the beginning of lines 3 and 4 is you say source. So actually using that dot right there or writing the word source is basically calling a script file, and they can be used pretty much interchangeably. There might be some exceptions to that, but none that I'm aware of. Okay.
It's good to know.
So we need to source these 2 files. Where are they? Well, they're supposed to be one directory up from the directory we are working in right now. Yep. So if you cd ... and then ls again, do we see those files? Well, I see utils.sh. That's good. So line 3 is going to work. But line 2 is not going to work because there's no env.sh file. So what you can do right here is you can say touch space env.sh.
ENV.
Yeah, and then go back and well, now you can change the file name, right? So you can say mv ev.sh env.sh.
Space ENV.
Yeah, space. So we're changing the name of the file. So
No, you had it right. Yeah, sorry.
you currently have a file called ev.sh. So we type ev.sh, then we type a space, and then we type the name that we want to change it to, which is env.sh.
Okay, that makes sense.
Okay. And now inside of this file, there's a few spots you can go for this. And close that tab, right? Because ev.sh doesn't exist anymore. We just changed the name of it. And we want to open up this env.
Open up as in like in the editor?
Yeah, okay. So now it's open. That's great. Now we also want to open again the 001 deploy reference script. Now, what we're sourcing from the env file is 2 things. One, the sender address that we're referencing on lines 12 and 20.
Okay.
Okay.
Should I
And
just
2,
mhm.
yep. And the other thing we would need to reference is the sender key that we're talking about on line 24. So in your env.sh file, we need to set 2 variables, sender and sender underscore key. So drop back into env.sh. The
Is there
first
a
line,
reason like a new tab is not opening and like the same tab?
it's a VS Code setting. If you want tabs to stay open, after you open them for the first time, double click on the tab and you'll see the file name go from italics to non-italics. And once it's non-italics, it'll stay open.
Over here? Am I looking here?
The
Or
tab above where, yeah, that tab right there. Just click on any other file and you'll see when you click on it, the name of it is in italics. You see,
I see, I
double
see.
click on the
Okay.
tab. Now it'll stay open.
Makes sense, makes sense.
So
Okay,
line
so
one, just type the word sender on env.sh. You don't need to copy anything, just sender equals. Perfect. And then on the next line, you saw the autocomplete was already working because there's some nice IntelliSense related to shell scripts here. So start typing sender again. If you want to use the autocomplete that shows you sender underscore key, you can.
auto sender key, you said. Oh,
Type sender again. And then you see the autocomplete. That's the one we want. Yeah. Sender underscore key equals. Okay. So now the sender is the address. Open up that wallet you just created and paste the address on line one. And then as for the sender key, we have an environment variable right here, right? The env file is in what directory? It's in module 203, right? And you also have, right? You also have this CLI wallet right here, right? And it's, well, you know what? Erase what I just said. We're not going to yet, not even going to explain that one. Just right click on the file payment.sk. If you right click on it, or like control click, and let's copy the path. I'm actually curious how this will work in Demeter. And let's just paste the entire path. Yeah. All right. I'm hoping that works. This /config would be your root. Let's try it. All right. So save this file.
Which I think it does automatically in there
Automatically?
for
Okay.
whatever. Yeah.
Great. And now we want to run that 001 script again with the same command we used a few minutes ago. But we need to go back into that directory, don't we? So CD, and then it was SLT 2034. So just start typing SLT and then press tab. Okay. Now press the up arrow. Yeah, until we get to that last time we used 001. There it is. All right, let's see what error we get this time.
Because we knew there was supposed to be an error, but we
Okay, the TX out is not working because, okay, so this is happening because these scripts were not written specifically with Demeter in mind. So we're going to do a little bit of troubleshooting right now. It's actually going to help me learn a little bit about how Demeter works. So a little bit of inefficiency coming up, but let's try this. One of the ways that I troubleshoot a script like the one we're trying to use right now is as follows. Go back into that 001 file. And what we're going to do is first, we're going to comment out lines 23 to the bottom of this file. So just highlight lines, 22 to the end. Oh, and I'm going to show you a shortcut. I'm going to teach you a new trick right here.
okay.
Highlight those lines. Press Shift and the down key.
Oh.
And keep pressing down. Does that work?
Oh, yeah, yeah.
Yeah. All right, now press Command slash.
Which direction?
The one with the same button as the question mark.
Okay. Okay,
There we go.
perfect.
That's how you
Okay.
comment multiple lines at the same time. And you can
Yep.
uncomment them the same way. You can just type the same command again. You can toggle them
Okay.
on and off. Then what we're going to do is we're going to wrap our transaction build in an echo. Watch this. Go up to line 15 or whatever it is, 13. On line 13, type echo space quotation mark. And then go to line 22 and close those quotes. Okay, save this file. Looks like it maybe did automatically. And let's run this command again in your terminal. Okay, so you see what just happened. All the way at the bottom, it's not much. That's from the last one. You see,
Oh,
you just ran this command, and all it did is it printed this Cardano CLI transaction build. Let's look through this. It looks like the TX in is showing up just fine. You see it there, E1DEF. That's the one UTXO in your wallet. So that looks good. But then this TX out just has a +0. It's missing an address. You see that right there?
Yep.
Highlight the +0.
oh,
There it is.
Right
Yeah.
there. There's supposed to be an address +0. Why is that address not getting to us? This is great. All right, let's go take a look. Now let's go back to the script because certainly that's a problem. And that's supposed to be our reference script's address. Ah, but we didn't define that. Of course we didn't. Now there's a few different things we could do right here. One, we could add a reference script's address to your env file so that you would have one. But to make this faster, all we're going to do is we're going to use the same address as your sender address, and we're just going to store a reference script at the sender address. So on line 18, replace reference script's address with sender. Okay.
Yep.
And this will actually work. You could just run that command again, and we're going to see that the address prints where there used to be no address. Yep. See the difference?
Nice. Yeah, TX out, Scott.
And everything else here looks good.
+0.
So now let's go back into your 001 file. Let's delete line 22, those quotes. Yeah.
so I just do a command down arrow this time.
Command slash again, yeah. Just make
Oh,
sure. But yeah, the up and down arrows are for highlighting the text, but
oh,
the
you're
mouse
right. You're
does that
right.
too. Yeah. There you go. Okay. And then we just got to get rid of the quotation marks on line 22 and on line 13.
Remove echo as well, right?
Yes.
Okay.
All right, let's run this guy. Okay, that's the error we expected. Let's read
Okay.
this error now.
Ugh,
Minimum.
missing
Okay, so
missing
the
the color
minimum
coding.
threshold for output
There it is. That's it, huh?
is 4. Okay.
Plain English, what happened?
We didn't specify the UTXO that needs to be used for this transaction to actually create other UTXOs?
We absolutely had a UTXO. We specified it right there, TXN E1DEF39. We specified a UTXO.
Didn't have enough Lovelace.
Which one?
Hmm.
Minimum UTXO threshold not met for what?
Uh,
It says for TX output, right?
aha. Okay. Minimum TXL.
What does minimum UTXO for an output mean? That means like these many Lovelaces need to be sent out in the transaction?
Correct. This UTXO won't be valid without this minimum number of Lovelace.
So basically, like in our original UTXO that we would be
Oh,
using, you need this plus whatever is the transaction fees, right?
Yeah, we will. We will. And that part's taken care of because we have a helper utility that's pulling the biggest UTXO from the wallet. And by the way, you only have one UTXO right now, right?
Okay,
But
yeah.
we need some minimum, what's that for? Almost 5 ADA, right? I thought the minimum UTXO was closer to 1 ADA. What's going on here? And by the way, those last 3 errors, we can ignore those. Those are just telling us that the first part didn't work, right? There's no draft of a transaction because step 1 resulted in an error. And then obviously we can't sign and submit what's not there. So we can zoom in only on this error right here. And it says min required UTXO is 4.9 million Lovelace. And that's a lot more than the typical min UTXO, which is approximately 1. And then obviously it goes up if you start adding tokens to a UTXO. This one is much bigger than we might be used to because we are trying to put that entire CBOR string that we compiled earlier into the UTXO, meaning it's going to be bigger, meaning it needs more Lovelace. Okay. And because I didn't know exactly what that minimum would be, right? I knew it would be pretty close to this number, but it actually, what it exactly is depends on the, oh no, well, our policy ID is always the same length. So this is, yeah, this is never going to change. But the reason I'm showing you this is that often you might not know what the min UTXO required for deploying a reference script is going to be. And just to put this all in clear context, can you open up that 001 script again? Just drag down the terminal so we can see it. Yeah. Right. So right here, line 18, we say, okay, we're going to send to some address a UTXO with some amount of Lovelace. We don't know how many. And on line 19, we say, include in that UTXO this validator script, right? Line 19 is the thing that's going to make this a big, important UTXO. Line 18 is where we specify how much Lovelace to include, and it's very common to not know how many Lovelace that might be, okay? Now, there's better ways to figure out what that amount is than what I'm showing you right now, but at least this is a place to start. And so here's the idea. You can go back to the lesson to see the punchline as well, right? We see this error. And then we just replace the 0 in our previous command with the amount that the error told us was the minimum.
Ah, sneaky, sneaky. Is that like a good way to figure out like what the minimum is?
It's
Where's
a
that
really
minimum number
efficient
come?
way. Yeah. And because these error messages always take the same format, you could even automate. You could build the transaction once, right?
What?
You know it's going to be an error. You can grep that number and then you can run the build again with that number. So you can actually automate these two steps into one. We're doing a little bit of cut and paste in between.
It seems like a helper function
It's a nice
somewhere.
one. It's a fun one to write too, like as a learning bash and string manipulation challenge.
Yeah,
That would be a satisfying one to take on.
that would be very cool. Yeah.
So just in your terminal, Harsha, just press the up arrow one time so we can see this line again and just replace that 0 with the number we're being told. Go for it. There we go. Transaction fee, a couple cents higher than usual, right? And then remember, take us back to line 33 on the script. Remember, there was going to be some output. Can you find that output file?
It'll be in the same. What's it called again?
The green ones are the new ones, remember?
Reference script dash something. There it is. Reference script. Yeah. Nope. Down. Yep. I think.
That's yeah. Your mouse was just on it. Go back to, yeah, right there. That's it. That's the one. There. All right, look. That is the hash of the transaction that you just built with the 0 we know that our index must be. And let's just copy that transaction hash and bring it over to preprod.cardano scan.
Nice. Okay, cool. Zero.
And get rid of the hashtag 0 at the end of it.
Oh, yeah.
All right, when did this
Yes.
transaction happen? Oh, a few minutes ago. Great. How many UTXOs did it have in and out? Any surprises here?
2 in.
Yeah, 1 in, 2 out. Yeah.
1 in.
Yeah, this is the 1 in. These are 2 out.
Yeah, so that's showing you. Yep,
Oh, that's showing
it's
the
one
address
in.
and
There's
in.
2 lines in the inputs because it's showing you the address that it came from and then the UTXO that was spent.
Right.
Now these 2 UTXOs, look at the amounts on these. What do you notice?
Huh.
4.93495. Where have we seen that before?
That's the number we changed.
That was the
Oh,
new
no,
UTXO we
that's the
need.
minimum. Yeah, the minimum.
And we
someplace.
needed that because we were attaching some data to this UTXO. And that little orange circle is Cardano Scan's way of saying, hey, there's some data on this UTXO. It's a script. It's a Plutus V2 script with a long string of CBOR.
I've seen that. I know that CBOR. I memorized it a little earlier.
See, you had the chance. And it's expensive to put all of that CBOR on chain. It costs 4.93 ADA as a min UTXO to store it. How's that feel?
Mhm.
Pretty good, yeah.
Cool.
Yeah.
So
Love
now
it.
with this thing deployed, now this min UTXO thing is kind of interesting. And with a really advanced validator, you can get north of 20 ADA for the min UTXO. So one question that follows is, well, is it worth it? And it's worth remembering that before we had reference scripts, you used to have to attach that entire CBOR string to every single transaction. That made the transaction itself much, much bigger, and it led to exorbitant transaction fees. Now, instead of putting all of that CBOR in every transaction, we don't have to do that anymore. We can just feed this transaction hash, the hash we're looking at right now, D98CCE, right, which you'll see at the top of the screen or in your address bar. We feed it that transaction hash, index 0, and the blockchain, as it validates against the logic we wrote in Aiken, it looks for the script that's already saved on chain. And we save in transaction costs because we've kind of fronted this deposit, right, to store the thing on chain. Does that tie together for you?
Yep, yep.
I think so.
So if we go back to Demeter, we can see this in action. After script 001, we've got script 002. Let's read this one.
So these are the key ones, right? Or no? Mint policy ID. Wait, this is a mint references pair. Okay, okay. So this is what the example does.
Now notice that there's no validator logic in this one. Not yet. Here we're just
Okay.
minting 2 tokens. Okay. How many outputs is this transaction going to have?
3.
Three,
3.
right?
Exactly.
Because,
Yeah.
okay, yeah.
Yeah. The output on line 37 is pretty boring. It's just going back to some receiver address that we specify as a command line argument. It's sending 2 ADA plus the 222 token. It's going to some wallet, right?
Mhm.
The one on line 38, that's very exciting because it's followed by line 39.
Aha.
Where's that file? Reference token datum.json. Can you find it? Now, does that look familiar?
Yep, yep. Okay.
This is that's
This is
68747. That's the
Oh,
HTTP or something.
HTTP / /
Oh yeah,
Okay.
that I think needs to be someone's username. Definitely. It's a good one. But what is 6465? Wait a minute.
this
Yeah,
is
go decode
the
that.
message that we put in, like
Yep, that's right.
name of yeah.
like just a G or something.
Whatever this
Yeah.
one was. I know that 64 and 65 are right next to each other in the alphabet. So those are 2 consecutive. I don't remember what we left that one to be. Can you decode that?
I will check.
I bet. There it is, the bottom there, string.
Oh shit, I
Keep it
forgot
going.
hex.
Ah, they all work. Yeah,
They
whichever.
all work, okay.
Yeah. Hex, do we want hex to string? Oh, this is just numbers?
Oh, I have no idea what this is.
Hit up on your okay. Go into your address bar and
Let's see what happens.
binary.
Oh, these are
Sweet.
again, it's just converting
These are
numbers.
numbers.
Yeah, go up into your
I forget what is the one
It's
that we
string
use?
functions. Try typing string functions up there.
These
String dash functions. Whatever. I'll
doesn't
find
matter.
it.
Yeah, let's skip
Yeah,
it.
it just says
But yeah, we're just trying to.
there it
There's
is.
the
There
one.
it is.
Description. Okay.
Description. DE. Here, mystery solved.
All right. It's like a Wordle. It's like, okay.
All right. So on this mint reference, we were back on 002, right?
Mhm. And the reference token datum we just saw.
Then we're minting. And what are we minting?
The
Script file path.
Right? That's going to tell us how to derive the policy ID. So line 41 has to match the policy ID that we're referencing on lines 37 and 38 in order for this to be valid. And on 40, yeah, 37, 38, and 40, we reference some policy ID. Where's that policy ID coming from anyway?
Let's see. Did we here? I think we're calling it from here minting policy 2034 reference token.
So you might have to change that path to match your test token. Okay, so if you left it with these defaults, you would use some policy ID that was already made, but you can change this, your mint script file path. Oh, 00, we closed again.
Oh,
All right. But now before we paste, let's just think about relative directories. You are in SLT 2034, right? And you're in the same directory as the test token subdirectory, right?
so yeah, yep.
Right. So yeah, that means that paths like these should work. On line 14, you should be able to replace the minting policy before the slash with test token. And then this is the script file. What was the file name there? Can you
This one?
drag, can you make that column a little wider? Just so we can see the
This
full
guy?
file names?
This
Yeah,
one?
drag that to the right. There we go. Script, mint-test token.script. That's what we want on line 14. And it looks like it's mint instead of minting. I'm looking at, move your mouse up a little bit, right? Oh, yeah, we want that file name to match exactly what you see in green, right there, right there. Right, one up, that one.
Okay.
Yeah.
Okay.
Yeah, that file name on line 14 has to match exactly.
yes, yeah, it's a
There you go. Now the one on 15 has to match the S key, and it's actually the same. Right, so now you can just you can copy everything in red before the dot on line 14 onto line 15 and onto line 16.
So just this one, right? Yeah, so I'll just copy this and then change this.
Right. And then the currency symbol, the CS that's our policy ID. So you have cat just test token / test token.cs. And you use / test token there because the first one, right? It's the directory name. It's also
Oh.
file name. You see how on line 14 you have test token / file name. And on
Oh, okay, okay,
15,
okay.
same thing. Here you want test token / file name. That's it. There you go. Now
Can
this
we?
validator path, right? Line 18 is included not because we need to reference this, but because we're deriving an address. So line 18 is used on line 20. And give us one of those option Z's just to wrap the text.
This text?
Just
Yeah,
press,
if you do
just
it.
tap option.
There you
Yeah, there you go. Right, so now it just wraps it so we can see that whole line. So Cardano CLI address build, testnet magic 1 for pre-prod. The payment script file is this validator path variable, which was defined on line 18. It's the name of the Plutus file from which we are, or to which, or from which we're going to derive a address and to which goes the 100 token, right? Now, what was the name of yours? It was, we moved this over a few minutes ago. Find the .plutus file in that directory over there. There it is, reference token pair Aiken test token. So on line 18, that's the file name we need.
And
Just
Plutus,
add a
this one, right?
dash. The green one is yours, right? That's the
Oh,
one
okay.
created. So it looks like you just need to
Token.
add dash test token. Right there, perfect. Okay, so we provide this validator script. We just generate an address for ourselves automatically. We grab the UTXO from our wallet. We generate the two token names. And by the way, on lines 27 and 28, that's showing you a little bash that you can use to convert a string to hex without going to a website to do it, right?
go. Nice.
And this can be done in the other direction as well. That's a fun challenge to try to learn how, but there's some nice syntax there that you can study. But I think we've got everything we need here to mint this new token pair. Should we give it a try?
Yeah.
Oh boy.
And let's look. So we're going to run .002, but we got to check what the command line arguments are as well. So scroll to the top of that file.
Top of which file?
Yep,
This one?
that one.
Yep.
Yeah.
Oh, okay.
Looks like we need to provide a receiver address and a token name.
10 and 11 there. The args.
I'm gonna copy that and change it in the
Oh,
terminal.
okay.
So token. So we can name the token anything,
Do a
right?
quick,
Like
hey, can you do a quick Control C just to move to the next line and clear out your terminal? Do clear. Yeah, try it again.
no.
Just you can paste it again. Control C again and clear. All right,
And
so
we can
now
name the token name anything or
anything you want. Yep.
Oh,
And then you can decide if you want to send this back to your Cardano CLI address so that you can use script 003 and try to update the data, then you can just send it to yourself. Or if you'd like to send this to your Eternal wallet, and learn how to configure the front end for your contract, you can send it there. Or you can do both. You can mint one to your CLI wallet and another to Eternal and play with both of them.
Okay. Mm, receive. So how do I do both of them? Like the receiver
You'd have to
address
run
would be.
this, you'd have to run this command twice, one for each receiver address.
Oh, okay. Okay.
And then you would probably want to give each one a different token name as well. We haven't done anything in this script that protects duplicate token minting, but that's something that we'll want to do eventually.
Uh, this,
Cool. Let's see if it works. Mint reference asset pair. All right. Does it say what line that problem was on? Mint reference asset pair. Oh, sorry.
That's
Yeah, the usage is not quite up to date. And so you can see the name of the file we're working inside of doesn't match that usage comment. I'm sorry about that, but that gives us a chance to use the command line instead. So instead of copying and pasting this time, type /002 tab. Now
there it
paste
is.
the address from Eternal. I think it's still in your clipboard.
Yeah,
Yeah,
put in
and
the
then type a token name.
yeah.
Try that. There we go.
beautiful. Okay.
All right, so now you've got a token pair. You sent this one to Eternal, and now you can continue with the lesson and see if you can run locally the Plutus PBL project with your instance instead of the built-in instance, right? Which would allow you to change the datum on the tokens you just minted. And that's a fun thing. We could pick up there next week, and we'll just keep
Love it. I love it.
going. Yeah, this is real. This is really good. What do you think, Harsha?
I really like it. Yeah, I'll just like send the other token, the reference token. So there is no difference between the reference token and the token that exists in your wallet, right? For the most part, you just send two tokens. Oh, but it does have a different name. Okay.
Yeah, go to Eternal. Let's close out by looking at that transaction, right? Did that come through yet? It sure did. How many outputs? 3, just like we said there were going to be. What are they? There's the 222 that you got. There's the 100 that goes orange to a script. And then there's
Wow.
the change that went back to the sender.
Okay. Oh, so I thought this was a separate transaction. So both of them, when minting itself, both of them are minted together. Okay. Okay.
Yeah, and the only reason they were both minted together is because we chose to do it that way. In the 002 script that we just ran, look at line 20 something, 30.
Reference address.
Well, there's that. That's used on line 38. Now I'm talking about line 40, I guess. Yeah. What did we mint?
I see. Mint script file path.
Line 40. Line 40. Mint one token with this policy
Also,
and this token name, and mint another token with the same policy ID, but a different token name.
and this is the mint script. Oh, but this is the script. Where did we mention the script address? I just the one where the 100 token went to.
Line 38. We got the reference address.
Oh,
Yeah.
okay, okay.
And that
Makes sense.
reference address was derived from the Plutus script automatically up above, right? We actually haven't even looked at what that address is because we let the script just create it for us.
Oh, okay, okay, that makes sense. Okay, perfect.
That's cool.
Progress, y'all. I like it.
Yeah.
Yep.
Yeah.
Yeah, now I feel like I'm slowly understanding how to work with a validator script.
You're learning so many things at once right now too, so it's hard to separate things. But I like where this is going. Yeah, I think we're putting some really nice pieces together. So yeah, try on your own to mint another token directly to your sender wallet, and then
Mhm.
see if you can get working the 003 script, which is finally, and let's look at it real quick while we're here. Right, 003. This is a Cardano CLI version of the transaction that you already experienced on the front end where you changed the URL of the image associated with your token. Right?
Oh, I see. Okay.
Right. Now this is going to be a much more complicated looking transaction. If you scroll down a bit, right? 3 different inputs, 3 outputs once again, some collateral, right? But then lines 43 to 47 form a block. Right? 43 says, okay, spend this TX in. 44 says, oh, that TX in, you're going to need a reference script to spend it. 45 says, well, and that reference script is a Plutus V2 script. It's got some inline datum on it that you want to look for. We're going to make this redeemer that states our intention, and you can look at update-redeemer.json to see how it compares to what we already looked at yesterday. I would like to change the image URL to line 5. I would like to change the description to line 8. And this is my token name, line 11.
Hmm.
And line 11 will have to be changed to the name of whatever token you're trying to use. Otherwise, this validator won't pass.
Makes sense. So, okay, okay. So when we say token name, are we referring to, because we have used those numbers 100 and 222, right? So they are not a part of the token name, just the remaining part is the token name?
Go back to the Aiken validator to answer that question.
Validator.
Reference token pair. Validators. That file. Remember that in our redeemer on line 20, we specify the token name. This is the token name you're asking about right now, right? And what do we do with that token name? Well, we pull it in on line 29. We destructure the redeemer and we say, okay, there's going to be a variable called token name. And then on lines 35 and 36, we use that token name. We say, okay, whatever token name they told you in the redeemer, let's assume there's 2 tokens in this transaction, and let's just put a 100 on front of that token name and a 222 on front of it.
Oh, yeah, I do remember this from yesterday. Yeah, that makes sense.
But it comes together now that you're kind of seeing it from the full perspective, right?
Yep.
And so in the redeemer, yeah, there's not going to be a prefix on the token name. But in our validator, we take the token name specified in the redeemer and we say, okay, we're going to assume that this transaction has tokens with these names based on what we were told in the redeemer.
Makes sense.
And it's possible to build this validator without specifying the token name in the redeemer, but I wanted to show you this part in particular. Okay, so
Mhm.
hopefully this is helping you wrap your head around how redeemers work and what's possible. But it is also possible to write this validator in a way that we don't specify the token name in the redeemer, but we do somehow compare the names of these two tokens. But we'll leave that as an exercise to see if anybody wants to try to
Yep.
update this and what that would change.
Makes sense.
All right, y'all.
Yo, we went way over time, but hopefully we're making progress. Thanks for jumping into it today, guys.
Oh, definitely making progress. That was super great. And like you said, there's just so much like learning all the environment stuff and little shortcuts. These are really how, in a whole way we level up. I'm not picking up everything, but I'm certainly able to make the next step. And it's really pleasant. It's time well spent.
Yep, I agree.
Have I told you my story about scissors? Just real quick. So when I was teaching ninth grade math, and I thought I was a math teacher, and we did this project where kids were going to learn more about like how multiplication facts had patterns in them by doing a project where they had to cut out pieces of cardboard and they were going to use those numbers. It was a very interesting project that really built number sense. But we start the project, and one of the students came up to me and said, I actually don't know how to use scissors. And it changed my life. I was like,
Yeah.
well, damn, I'm really happy I know that because I can help you with that, right? Like,
Yeah.
screw
Yeah.
math. I don't care if you ever learn math, but you're damn well gonna want to know how to use scissors in your life, right? So like we keep creating situations where we pick up valuable skills, and whatever the intention of the teacher was, it's great. Maybe some students will catch up with that, but everybody's going to learn something. You just never know exactly what. It depends on what each of us need.
Yeah. Yeah. And then it all does come together, which is kind of cool.
Yeah, well, builds. All right. Thanks for the inspiration, team. Have a good
Hi,
day.
James.
Yeah.
Thanks.
See you tomorrow. Yep.
Thank you,
Ciao.
guys.
Bye.